In this video, we're going to look at how we create an ion. Ions are going to be an atom that has lost or gained their valence electrons. A cation is going to be a positively charged ion. They will have lost their valence electrons. So if we're looking at the symbol here of Na+1 and Al+3, we know that sodium has lost 1 electron and aluminum has gained 3 electrons. Our anions are negatively charged ions. So that's when we've gained valence electrons. So here we have our chlorine at a 1- charge. That means it's gained an electron. You might see it be a -1 charge, and that's okay too. It just means it's gained an electron. Oxygen here at a 2- or -2, that means it's gained 2 electrons. Our polyatomic ions are going to be covalent molecules with an overall charge. So if we look on the back of our periodic table, all of these are common polyatomic ions. You will never have to memorize these, you just need to know where to find them. So here we have nitrate, which is a covalent compound, but it has an overall charge of a -1, which means it gained an electron. So let's talk about creating an ionic bond. We are going to be transferring our electrons from the cation to the anion. And when we do that, the sum of our ionic charge is always going to turn out to be 0. So in this case, our sodium lost 1 electron and gave it to the chlorine. The chlorine gained that electron, and so we have a +1 charge here and a -1 charge on the chlorine, which gives us an overall charge of 0 on that compound. So let's go ahead and start talking about how we form some ionic compounds. We are going to turn them both into ions first. So if we look at the periodic table, we know that magnesium has 2 valence electrons. It's going to lose both of those electrons and create a +2 charge. Chlorine, if we look on the periodic table, has 7 valence electrons. It is going to gain 1 electron and have a -1 charge. Now let's talk about the why here. Magnesium and chlorine want full outer energy levels. It is easier for magnesium to lose the electrons than it would be for it to gain 6 electrons. It is much easier for the chlorine to gain 1 electron than it is for that chlorine to lose all 7 of them. So first we create the ion, and there is a trend on the periodic table that we'll go over when we see each other in class. Our next step is to balance out the charges, and we always have to remember that the cation gets written first. So we have Mg at a +2 and chlorine at a -1. Right now, if we were to add that +2 and a -1, it is not going to equal 0. So we can add another chlorine ion, and now our overall charge is a -2. Our charge here is a +2. So we're balancing out our charges. Our next step is to write the number of each ion as a subscript. So we have 1 magnesium, we have that invisible 1, and then we have 2 chlorine ions, so it'd be MgCl2. Our transition metals don't always have set charges, except for aluminum, zinc, and silver. These are the ones that you have to memorize. The other ones, I will give you some kind of information to help you determine what that charge is. But aluminum is always a +3, zinc is always a +2, silver is always a +1. So let's go ahead and create the formula between Cr+2 and chlorine. Now, I gave you the charge here on chromium because it's a transition metal. So we know that chromium is a +2 charge. Chlorine, I'm going to have you look at the periodic table. It has 7 valence electrons. It's going to be easier for it to gain 1 and have a -1 charge. So that's going to be like that. Then we have to look at our charges. This does not add up to 0. So we can add another chlorine ion to get an overall charge of -2 and have an overall charge of +2. So then when we write it, we have 1 chromium and 2 chlorine ions. Go ahead and do Mg and PO4. So magnesium, if you look on the periodic table, has 2 valence, it has 2 valence electrons, which means it's going to lose those 2 and create a +2 charge. PO4 is on the back of the periodic table. That's a polyatomic. It's going to be a -3 charge. So we have Mg +2, PO4 -3. Now, anytime we have this 2-3 split, we're going to get it to 6. So that means adding another PO4 and adding 2 more of the Mgs. So we have a +6. We have a +6 and a -6, and we've balanced out the charges. So when we write it, there are 3 of the magnesiums, and our polyatomic ion, we actually have to put that whole thing in parentheses. There's going to be 2 of those. We're going to get a lot of practice with this. If you had any questions, go ahead and write it down, so then that way when we see each other, we can go over them in class.